Hey, I still get stressed even though I did this so many times before. Okay, so today I'm going to talk about improving developer experience. This is a huge topic, but we only have a little bit over 20 minutes, so I'll focus on some basic techniques and tools you can leverage to make your life easier. We all know what user experience means and why it's important. But what is developer experience, and does it really matter? So when I talk about developer experience, I think about all the things we do daily. Does it take long to verify the changes that you made to project are working correctly? Is maintaining our app complicated? How long does it take to reproduce a bug report? Developer experience has huge impact on the ways we work. If it's optimized, we not only enjoy our work more, but we also are more connected to the work we are doing. On the other hand, if it's bad, our work becomes dreadful and our teams become inefficient, which is why I think it's very crucial to use the right tools and architecture choices to make it easier for us. So who am I? I was introduced, but the reason you should listen to me is probably because I often get hired as a consultant to help teams become more efficient and improving their processes and architecture choices. My open source projects power up more than 30,000 applications, and I spent last 8 years working on tools and libraries that make life easier for this community. And all of that boils down to improving the developer experience. So the tools I created like Sourcery, Playgrounds, Bootstrap, all focus on making your life easier every day. So let's look at some of examples of issues that you can observe in iOS projects. So one of the biggest pain points in our community is a compilation time. Waiting for Swift to compile takes a really long amount of time in itself. But that's not the only time you have to spend, because every time you compile your project, you also have to relaunch the simulator, you have to navigate to the screen that the feature you're working on is, right? And you need to usually do some manual steps to reproduce the scenario that you are trying to either implement or fix. So let's say you're working on tweaking user experience or user interface, which is a very common task. You tweak the little things and need to see them in your application to verify whether they feel right or not. So if your iteration time takes 25 seconds, which is pretty decent for Swift projects, it doesn't seem like a lot of time, right? But let's assume that you work 8 hours every day. And I measured some of my own data when I worked on user experience, and I usually get to around 300 code changes per day. So that 25 seconds, each time I change my code, turns into more than 2 hours wasted watching build spinner and relaunching the application. That's 25% of my workday. It's not only the time that we waste here, but also the disconnect it creates. If you change the code and see the changes reflected immediately, you will try tweaking more values, you will experiment more. If it takes long, you don't feel like it, right? It's really annoying. So the easiest way to improve Swift build times is to use separate frameworks for different app modules. Not only does it improve your build times, but also it improves your interfaces and forces you to create a better public API design. When you have smaller frameworks, each of them can have fast-running unit tests that only need to rerun when the code changes. And that, in fact, significantly improves your TDD workflow. Those frameworks can also be used with playgrounds or sample projects to iterate over functionality or UI. And like the problem with loading, you can use static libs now with Swift, but even if you have to use dynamic frameworks, if you're still using some of the older pods, there is a way to improve it. You can use CocoaPod's Aminomo plugin that, when you build, compose all of the dynamic frameworks under your main application target. And that gets rid of a lot of the dilib issues. Sometimes you cannot split your project into frameworks. So what can you do then? You can leverage code injection. It allows you to reload the code in place without even having to restart your application. And there are two tools for that. One is injection for Xcode, which is an external application that you can install on your Mac. It doesn't even require you to unsign your Xcode or doing anything fishy like that. And code injection in Swift is pretty limited due to type system. But since our UI is based on Objective-C frameworks, most of the things that you do with your user interfaces or user interactions can actually use code injection. And here is an example of how code injection works. Basically, whenever you change the code, rather than having to restart your application, you just see the changes reflected immediately. So if I change a label, it will be reflected in the video, like as I am working. So this is the first thing you can use. The other tool you can use is a playground framework I created when Apple released first Swift Playgrounds. And if you were here for Swift 1.2 or one of the early releases, you remember that Swift Playgrounds were really buggy and didn't support user interaction, didn't support a lot of those nice things. So being dissatisfied with them, and since most people were still writing Objective-C, I've decided to write a better Playgrounds by leveraging my experience with code injection. So what's nice about those Playgrounds is that you don't have to split your app into frameworks. You can just add a Playground framework to your project and start working with it immediately. And they work with both Objective-C and with Swift. Recompiling the changes you are making takes less than a second. And you don't need to relaunch your application in Simulator. You just change your code and observe the changes reflected immediately. And my Playground is built on top of code injection. It adds extra DSL for you that you can use to automatically add UI elements. The UI elements can be a slider that controls the numeric value, an image picker to change the test image you are working against, stuff like that. It's very convenient. So the second issue we're going to talk about, dependency on data. In my career, I often hear people are blocked waiting for either backend devs to implement a new feature or some API change. But if you design your architecture in a right way, you can avoid this issue almost completely. In fact, most of the time, when I finish the native part of a feature, I usually do it before the backend is even complete. And I only need to verify that they have adhered to our agreed contract after they are done. So let's talk about how to structure our data architecture in a way that can improve our workflow in a couple of scenarios that deal with this kind of issue. So the first advice you'll hear in Swift is to use protocols. This advice is crucial if you want to do any kind of testing. But even without testing, it can give you a lot of benefits. And I think that one of the most important things you need to do when designing an architecture that deals with external data is to design it as a pipeline and have a protocol at each stage of that pipeline. So let's say I have a data provider that gives me raw data. It might be NS data or it might be JSON, doesn't really matter. A decoder that transforms that data into some basic objects, and then a converter that turns it into my model objects in my project. Whether persistence is necessary or not, that always depends on the project. At the end of this, I have a consumer. A consumer might be a view model, or it might be another model object that you use to do some business logic. In the next few minutes, I'll show you how a pipeline like this can be used in very different scenarios to improve overall developer experience. So let's say you need to write tests for your view model. Or you have a bug report that requires specific data configuration. We all know how that works, right? We usually get bug report, and it's really hard to reproduce because the data is no longer there. So with the pipeline architecture that we designed, we can just replace the model converter with fake data and skip all of the earlier parts of this pipeline. And this applies not only to unit tests, but also when you get that bug report. You can just put the data in your project and immediately launch a specific screen with that bug configuration. This works great for static data. But how do you verify that your data mutations are handled properly in your project? So let's say I want to see how my whole application reacts to specific data changes, but the backend isn't ready. Getting changes, even on staging environment, is problematic. And in big companies like the Times, for example, it usually involves coordination with other people and teams, which is very inefficient, as we all know. As an example, when we were writing section front for the Times, which is the part that displays all the articles, we didn't have the servers ready. But we wanted to ensure that based on different data configurations, our layouts would work correctly. So we had unit tests for most of the components in the application, but to be able to see the whole thing come together when servers aren't working, we had to come up with an alternative solution. And we could be storing a JSON file on a server and reloading the app each time we change that. But that would be extremely tedious and would mean a really long iteration cycle, which we are trying to avoid. It also wouldn't allow us to observe changes in real time, only proving that our initial load works correctly, not that our mutations are working as expected. So I started to thinking what we would need to do to make this mutation possible. And if we have a simulator, we can just load the data locally from a desktop file, for example. But if we are running on a device, we want to be able to load remote resource. And we want all of that to always have real-time updates. So whenever you save a file, the changes should be reflected in your application. So I thought, like, let's write a dev tool for it. So what I did is I wrote this very generic file watcher, and I open sourced it. It supports both local and remote files. This means you can put a file on your desktop folder or on Dropbox, AWS, and whenever you change that file, you will see changes reflected immediately in your application. The way it works with the architecture that we designed a couple of slides ago is that we just replace the basic data provider with our file watcher. The interface for that takes 3 lines of code. It's ridiculously simple. So when we replace that, it just starts picking changes in real time. And I actually dig up some 2-year-old video from when I was writing the New York Times front end. And our servers weren't ready, our designs were non-existent, but we could already work on the architecture and make sure it's working well and efficiently with real-time updates. As I'm changing some JSON file here, and the moment I save that file, the changes are reflected immediately in the application. So they go through whole architecture the same way a data feed update would. So this has significantly improved our efficiency as a team. And we were able to implement and test most of this section front before the backend was even ready. It's extremely simple, and it's very powerful. Another issue that I see very often. Most applications have some kind of manual data entry. An example might be a login screen or a creation workflow, like in Instagram when you create a post. That's a lot of manual steps. What's not necessary, though, is entering that data whenever you're working on features related to it. So if I was working on Instagram, I wouldn't want to have to every time create a new post and have tons of fake accounts or hundreds of the same posts. Rather than manually typing information into a simulator or the device, you should be able to automate it for yourself. So one use case is filling some basic credentials, login credentials. So the easiest way to fix this is to use user breakpoint. When you add a breakpoint, it allows you to execute an expression each time a breakpoint is reached. So what you can do is you can go to your view and add a breakpoint that will automatically fill your login credentials. And user breakpoints never leave your machine. They don't generate code changes, and they're never committed to your repository. So you're safe to store some sensitive data even there. Everyone on the team has their own user breakpoints. They never have issues between, like you don't have diffing issues and stuff like that. And they are also trivial to disable, since you can just unselect it and enter the data manually if you need to. But sometimes user breakpoints aren't enough because you need to take many steps to reproduce whole workflows. Or if you are working on a feature that will take you a long time, but you need to commit it to develop branch. You can add a build script to your project that will allow you to write code paths that execute only for a specific developer. So if I run my project, I can have special code execute just for my machine. If someone else on my team runs it, that code never happens. It's not even compiled. So you can use that to automatically jump straight to the screen you need to work on or reproduce specific issues and stuff like that. Very convenient. So let's say you have hard time reproducing bugs. One of the best techniques you can use if you use an architecture like MVVM is to serialize your view models when the user reports a bug. So that's the simplest thing. But if your reporting functionality is not available from every screen, which is pretty common, like you usually have report issues from settings hidden somewhere. So if that's the case, then you have to come up with something else. And the easiest thing you can do is to build least recently used cache and store all serialized view models, let's say like last 5 view models. Then when the user goes to that screen, you can just attach it with a bug report. That way, when you're having to reproduce the bug, you can actually load that data into your project. Alternative way requires a bit more work upfront and a specific architecture that leverages either unidirectional data flow or view state. And when you have those kind of architectures, you can implement something called time travel. A time travel allows you to reproduce all user actions and data that they have seen. This makes reproducing 95% of bugs ridiculously simple. It creates an amazing developer experience. So this is a simple project I wrote a couple of years back that leverages time travel and ability to record user actions. You can see that when I load a bug report after restarting the application, I can even reproduce asynchronous operations, including the timing, which makes it amazing to work with. Because if you had your application crash on a remote location, you can just load that report and you can just reproduce step by step with a debugger connected. Which means when it crashes again, you actually have everything, including the data, including the call stack. It's really amazing experience. I highly recommend trying something like that. And the last issue I want to talk about is boilerplate and tooling. And I think that writing boilerplate code and having inferior tooling is offensive to us as programmers, since we shouldn't need to write the same code for different objects. Oftentimes, the limitations in our tooling or the programming language itself force us to do that, to deal with this churn every day. Our tooling can also be limited and sometimes force us to do things in an inferior way. An example might be using strings rather than typed API for accessing resources, which we all know strings are very buggy to work with. So let's say you have to maintain the SALI algorithm for different types in your project. Even though Apple has recently been making progress in giving us derived implementations, they are still pretty limited. The moment you need to have a custom handling for one of the properties you use, you have to implement the whole implementation yourself. And like this is a shameless plug, but the whole thing is, there is one tool you should use if you run into this kind of issues, and it's called Sourcery. And I was getting hired to work on different projects. And every different project I work with, I noticed they were writing the same kind of code each time. So that made no sense to me as a programmer. Why do we keep repeating the same boilerplate in different projects, in different teams? If all implementations are the same algorithm, we should be able to automate it for everyone. So Sourcery is not a code dependency for your project. It works more like a preprocessor. The code it generates is fully compiled. It runs through the regular Swift compilation. There's no magic there. And if you can describe an algorithm, Sourcery can generate the code for any type in your project. And Sourcery is used in actually over 20,000 apps as of today, I checked. And if at any point Sourcery stops working, you can just remove it and go back to maintaining the code that it generated by hand, which you would be doing otherwise. So there really isn't a real risk of using it. It's not like libraries that require you to inherit from specific base classes that when you have to get rid of them, you have issues. That's not how it works. So this can be called industry standard by this point. And even people at Apple use it, although they cannot admit most of the time. So they send me diffs in private messages so I can fix some issues, which is kind of interesting. And I am yet to see a project that could not benefit from using Sourcery. So let's say you're writing tests. So Sourcery can be used to improve your daily workflow, not just the regular boilerplate. but even your architecture. If you have ever written tests, you know you need to maintain a lot of fake objects for your test suites. Each time a protocol changes, you need to go and update the fake. This isn't necessary if you use Sourcery, since it can do it for you automatically each time. And most tests use equality comparison. So what happens when the equality fails? Xcode will show you a wall of text for both object descriptions, right? And it's up to you, a human, to compare two big printouts and see what's different between the objects that failed the equality, which isn't something humans are very efficient to be doing, right, in the first place. So this is how it looks when you have a failure between two composed objects. This is what Xcode shows you. A single line with a bunch of text. This actually shows only the first object. And now you have to press and see the whole thing, right? And then it's for this object, it's actually like A4 paper comparison, like the amount of text, which is ridiculous. So when you use Sourcery, you can go from this, which is terrible, to this, which tells you, okay, there is a variable called local name in your object at first index in an array that's different. And this is the value that you received, and this is the value that you expected. So this gives you property level difference, even in complex objects, arrays, dictionaries, everything. This significantly improves my TDE workflow. It's basically, like, I cannot even describe it, how this made me more efficient. I was writing Sourcery, and I wrote it for the tool itself. And it saved me so much time. It's just ridiculous that Xcode doesn't do it for you. So let's say you're working with assets. If you need to deal with any assets instead of code, a complementary tool for Sourcery that you can use is SwiftGen. It allows you to avoid using string-based APIs by making them type-safe and also offering you auto-completion. Proper use of assets is verified at compile time rather than creating runtime exceptions when you launch your application. And this ensures that all the assets that you want to use in your application are available, and you're never trying to use something that doesn't exist. So in summary, I wish I had more time to discuss those things, but I hope that I convince you that developer experience matters. Right architecture choices can make a significant difference to your team, efficiency, and satisfaction. And it's all about working smart, not hard. If you have to, like if you're a freelancer, oftentimes you work based on the hours. So if you can do something to get the same amount of work done in 6 hours rather than 8, you should leverage it. It actually ends up saving you a lot of money or making you even more money. So you can leverage a lot of the open source tools that myself and others in this great community have created. And all of them are free, and all of them, you know, you can use, you can improve, and we can make it better as a community. And don't forget to follow me on Twitter, since I actually do a lot of open source. I can be helpful. Thank you.